In this video, we're going to be talking about the root test to test for convergence or divergence of series. The root test is more limited in usefulness than some of the other tests, but when it can be applied, it's quite useful. It has a condition similar to the ratio test. When the limit is less than 1, the series converges absolutely. And if the limit is larger than 1 or infinite, the series diverges. This time the limit is the limit of the kth root of the absolute value of the kth term of the underlying sequence. Therefore, this works very well if the sequence has the form of something to the kth power, so that the kth power and the kth root basically just cancel each other out. So here it is. If the limit as k goes to infinity of the kth root of the absolute value of a sub k is L, some limit, which is greater than 1, obviously 0 or positive and less than 1, then the sum from k equals 1 to infinity of a sub k is absolutely convergent. On the other hand, if that goes to a limit, but it's greater than 1 or diverges to infinity, then the sum from k equals 1 to infinity of a sub k diverges. If the sum of the kth root of a sub k, absolute value of a sub k, is 1, then the root test is inconclusive. Just like on the ratio test, when we get a 1 there, we get an inconclusive or a result that doesn't tell us anything. So I'm going to do one quick example of this. So we're going to use the root test to see if we can figure out if this converges or not. We have a fraction, negative 2k over k plus 2, and the whole fraction is to the 3k power. And we're going to sum from k equals 1 to infinity. Well, we see a power of essentially k on the outside, so we're going to take the kth root of the absolute value and see what we can get out of that. Well, first of all, when k is positive, let's see, that k here is positive, that k plus 2 is positive, that negative makes it negative. So if we take the absolute value, it's just taking away that negative there. So that becomes 2 there. Then we have the kth root of 3 to the k. We're dividing that power by k. The k's cancel. We just get a third power there. Now, inside the fraction, multiply by 1 over k in the top and the bottom. So we get 2 over 1 plus 2 over k. Take the limit as k goes to infinity, constant power on the outside. We're just taking the limit on the inside, so that limit is 0 here. 1 plus 0 is 1. 2 divided by 1 is 2. 2 to the third is 8. 8 is bigger than 1, so this must diverge. So it diverges by the root test. So there's an example of the root test.